Hi guys, it is Monday of week 7, our last full week. Can you believe it? And today we're going to be talking about extracting the square root, which is page 281 to 282. So while you get that ready and you get a pencil, I'll go ahead and put it up here on the screen for us. Awesome. So sometimes when we are in a higher level of math, which you guys are totally climbing towards, we have square roots. And let's look at number 1. It says extracting the square root is the opposite of squaring a number. Remember when, let me see if I can shrink this a little bit. Do you remember when we were squaring numbers? And if we said 2 squared was 4, right? And 3 squared was 9, and 4 squared was 16, and 5 squared was 25, and so on. That's a really funny 5. Well, extracting the square root or finding the square root of a number is kind of like that in reverse. A perfect square is a number whose square root is a whole number. So look over on the side of the screen again. So if 2 squared equals 4, the square root of 4 equals 2. And if 3 squared is 9, the square root of 9 equals, what do you think? 3. And if the square root, or 4 squared is 16, well, the square root of 16 is 4. And 5 squared is 25, the square root of 25 is 5. And now these are called perfect squares. If you look at the bottom here, so let's just do number 3 and then I'll explain the bottom. The symbol for a square is the radical sign. This person right here is totally radical. If your parents grew up in the 80s, they knew radical, right? But this is called a radical sign. And it kind of just looks like a check mark with a line on top of it. It kind of looks like a division sign, right? A little bit with a little check mark added to it. It's called a radical sign. So let's look at 4. The square root of 4, or this right here, is read the square root of 4. What is the square root of 4? It is 2. So let's look at these here at the bottom of this yellow box. It says 1 squared equals 1 because 1 times 1 is 1. So the square root of 1 is 1. 2 squared is 4, so the square root of 4 is 2. 3 squared is 9, so the square root of 9 is 3. 4 squared is 16, so the square root of 16 is 4. 5 squared is 25, so the square root of 25 is 5. 6 squared is 36, so the square root of 36 is 6. So I have a question, and this is kind of a thinking question. What do you think the square root of 100 is? Think about it. What number times itself, or squared, a number squared, gives you 100? 10. 10. The square root of 100 equals 10. So without further ado, now these are called perfect squares. The numbers, here, let me get a different color for you. The number 1 is a perfect square. 4, 9, 16, 25, 36, 49, 64, 81, 100, those are all perfect squares. So let's go ahead and look at number 1. The directions for number 1 say write the answers, okay? I think we're totally capable of doing that. Number 1, I'm gonna go down so that way we can just move over little by little. So number 1A says 7 squared. What do you think 7 squared is? Is it 7 times 2 or is it 7 times 7? It's 7 times 7, so it is 49. How about letter E? We're going to go down. Letter E, 9 squared. Is it 9 times 2 or 9 times 9? It's 9 times 9, which is 81. Okay, what about 1/2 squared? It's 1/2 times itself. 1/2 times 1/2 is 1/4. Okay, let's move on to B, F, and J. B, F, and J, the square root of 49. Well, let's look at A. If 7 squared equals 49, then what's the square root of 49? What number times itself gives you the number 49? 7. Awesome. How about 81? And we can look in letter E to help us. How about 81? What number times itself gives you the number 81? 9. And look at 1/4. What the square root of 1/4? What number times itself gives us 1/4? Fractions a little bit more tricky, I will agree with you, because you're probably thinking, that's a little tricky, right? They are a little bit tricky, but they're not undoable. What we can do is kind of just look at the denominator, because we know 1, the square root of 1 is 1, right? And the square root of 4 is 2. So the square root of 1/4 is 1/2. Let's keep going. Oh, letter C. Let's look at letter C. We have 8 squared. 8 squared. 8 times 8. 64. How about 10 squared? 10 times 10. 100. How about 2/3 squared? Before you have a little bit of a panic attack, don't worry. Just write it out. 2/3 times 2/3. 2 times 2 is 4, and 3 times 3 is 9. So just like with those other ones, we are going to look at C, G, and K to help us answer D, H, and L. So letter D, the square root of 64. What number times itself will give you the number 64? 8. 8 times 8 is 64. So the square root of 64 is 8, and that one helps us, right? Let's look at G to help us with H. What number times itself? Remember at the beginning of the lesson, we went over this one, the square root of 100. What number times itself will give you the number 100? 10. 10. So the square root of 100 is 10. Well, let's think about letter L. We can look over here, but let's think about letter L. When you have a fraction and inside of a radical sign or the square root of a fraction, ask yourself, are the two numbers, in this case it's 4 and 9, are those two numbers perfect squares? And in this case they are. So then we can find the square root. What is the square root of 4? It's really this. It's really the square root of 4 over the square root of 9. So what number times itself will give you 4? 2. 2 times 2 is 4, or the square root of 4 is 2. And how about 9? What number times itself will give you 9? 3. So 3 times 3 is 9, or the square root of 9 is 3. So the square root of 4/9 is 2/3. Okay. Wow, we did that very quickly. Let's look at number 2. Solve these story problems. Okay. The area of a square is 36 square feet. What is the length of each side? Ooh, these are fun because we're going to be using square roots with these. Remember, whenever we have a problem that has a shape, what do we do first? We draw the shape. In this case, it is a square. So the shape is a square in this case. Okay? And this says the area, or our question is, what is the length of each side? So we don't know the length of the sides, and that's a little different for us, but we can solve it. We know that the area is 36 square feet. So I have a question. What is the formula for the area of a square? Do you remember? A equals S squared. Are we solving for area, or are we going to solve for the side? We're solving for the length of the side because we already know area. So what we're going to do is we're going to plug in what we already know. And in this case, we already know that the area, if we have A equals S squared, we know that the area equals 36. So 36 equals S squared. Now I'm going to come over here and write it. And I know that I personally prefer to have the variable on the left side of the equation. It is a personal preference. If you do not want to do that, you do not have to. But I'm going to rewrite it as S squared equals 36 because it reads better left to right, so I choose to have it on the left-hand side. So how do I solve for S? S squared equals 36. What's the opposite of squaring? Finding the square root. So do you think, remember when we're solving equations, we use opposite operations. Do you think we can use the square root to find S by itself? Because S is not isolated yet. S has a little 2 attached to it. It has a square. We can find the square root. We can find the square root of S squared and the square root of 36. Remember, whatever you do to one side of the equation, you must also do to the other side of the equation. So what is the square root of S squared? What times itself will give you S squared? S. So the square root of S squared is S. S equals, and what's the square root of 36? What number times itself will give you 36? It is 6, right? So one side is 6 feet. Now, before we take that as our actual answer, let's go ahead and let's try to plug it in. Let's plug in S. Sorry, guys. Let's plug in S to this formula. A equals S squared. 36 equals 6 squared. Does 36 equal 6 squared? It does, so we got it right. Good job, guys. Okay, so let's look at letter B. We have this story problem. The radius squared is 81 meters squared, or square meters. What is the length of the diameter in the same circle? So we know our question is, what is the length of the diameter in the same circle? We know that we should draw a circle. Okay, and we know our radius squared is 81 square meters. So our radius squared equals 81. And we need to find the diameter. What do you think we should do? Let's play detective. What do you think we should do in this case? Well, on our last problem, we looked at this right here and we said, well, S squared equals 36, and we were able to free the S or isolate the S by square rooting both sides. Do you think we could do that with this problem? I think we can. Let's try. Let's find the square root of R squared and the square root of 81. Well, if the square root of S squared is S, what's the square root of R squared? It's R. Equals, and what's the square root of 81? What number times itself will give you 81? 9. Okay, so we found our radius. Our radius is 9 meters, but we're not finished. The question says, what is the length of the diameter in this circle? In this circle here that we just found out, we found that the radius is 9 meters. How do we find the diameter again? We double it. Good. So we're going to take 9 times 2, which is 18. 18 meters is our diameter. Okay, one moment. I'll be right back. That was fast. Okay, now let's turn the page over to number 5. So we have essentially, I guess you could say we skipped over a couple things. The things that I would like to teach you in this last week that we have, I feel are more relevant. And so I've skipped over a couple pages. Don't worry. It will come up and you're going to be totally fine with the things that I have skipped over. It's nothing I would much rather teach you about negative numbers and about square roots, okay? So don't worry at all. We're going to be on page, so we're not doing this part right here, 3 and 4. But let's go to the next page and let's look at number 5. Flip it over. Convert these temperatures to the nearest whole degree. It means might be doing some rounding, right? Let's look at 5A. We have 30 degrees Celsius and we're converting to Fahrenheit. What formula are we going to use? We're going to use the F formula, right? Fahrenheit equals 9/5 C plus 32. So we're going to take our 9/5 times whatever C is and add it to 32. So let's do that. Fahrenheit equals 9/5 times 30 over 1, because remember, we have to, we have to put a whole number over 1 whenever we're dealing with fractions, plus 32. Now we're going to look at this part of the equation first, because with Pemdas, you guys will be doing some Pemdas homework tonight, or not homework, but assignment. With Pemdas, you have to do multiplying before you can add. So let's look. Can we cancel anything in 9/5 times 30 over 1? We sure can. The 1 and the 5 share a common, or the 1 and the 30, excuse me, the 5 and the 30 share a common factor of 5. So 5 goes into 5 one time, and 5 goes into 36 times. And guys, just to be safe, I like to rewrite the problem. So we have 9 times 6 plus 32. What are we going to do first? 9 times 6. Fahrenheit equals 54 plus 32. And just to be safe, I'm going to come over here and write this vertically. Make a little bit less mistakes when I write it vertically. 4 plus 2 is 6. 5 plus 3 is 8. So 86 degrees. Did I have to round on that one? No, we didn't have to round on that one. Okay. How about letter B? Let's look at letter B. 58 degrees Fahrenheit is how many degrees Celsius? Which formula are we going to work on? What do you think? The Celsius formula, good, or the C formula. So Celsius equals 5/9 times F minus 32. Let's plug in. Celsius equals 5/9 times 58 minus 32. We're going to do the 58 minus 32 vertically, so we don't make a silly mistake. 8 minus 2 is 6, and 5 minus 3 is 2. So we get Celsius equals 5/9 times 26 over 1. Now, do 26 and 9 share any common factors? No, they do not. So in that case, what we're going to do is we're going to do 5 times 26 and then divide by 9. Okay? So let's do that. 26 times 5, I'm just going to use a 26 I have here. 6 times 5 is 30. 5 times 2 is 10, plus 3 is 13. So we get 130. So Celsius equals 130 divided by 9. What do we do now? We divide. Yeah, it says right there, right? 130 divided by 9. And we are going to have a fraction, so we are going to have to round. 9 goes into 1. Nope. 9 goes into 13 one time. 13 minus 9 is 4. Bring down my 0. 9 goes into 40. 4 times is 36. Is that enough? Yeah, 4 times. And I get a 4 left over. So 14 and 4/9. Who remembers? With 4/9, what's your decimal going to be? Because when we are rounding, we want to put it in decimals. It's a lot easier to round that way. When you have 9 as your denominator, what is your decimal? It's your numerator repeating. So this is 14.4%. And now we need to round 14.4% to the nearest whole percent, or the ones place. So this 4 is in the ones place. This 4 is the box saying round up or stay the same. What do you think? Stay the same. So this is 14 degrees Celsius. Okay. I would like you to try letter C on your own and then come back and we will check together. So try letter C on your own. You will have to round in this one. Okay? Go ahead and try it. Okay, hopefully you've checked, or hopefully you've worked it out and you're ready to check. So when we get through this, we get 66 degrees Fahrenheit. If you did not get this, I want you to look at the way that I've done it. If you're still confused, contact me and we can go over it together, okay? Let's look at, let's look at number 6. It says find the answers. I have the area of a square. What should I do first? I should draw a square, right? I like to use different colors so it doesn't get boring for you guys. So I'm going to use a square, and I'm going to draw my square, and my square has a side of 9.3 inches. And I am finding the area of this square. So what is my formula? Area, we used it earlier today too. Area equals S squared. Area equals 9.3 squared. Okay, let's multiply. Is it 9.3 times 2? Is it 18.6, our answer? Nope. We're going to do 9.3 times 9.3. 3 times 3 is 9. 3 times 9 is 27. 3 times 9 is 27. And 9 times 9 is 81, plus 2 is 83. When we add this, we get 86.49. So our area equals 86.49 square inches. And I'm going to tell you guys a little secret. If we found the square root of 86.49, guess what it would be? It'd be 9.3. because we're finding we would just do the opposite of squaring. Kind of cool, huh? Okay, let's go down to number 7. Number 7 says complete the chart. If necessary, round to the nearest hundredth. Now, what I want to focus on is finding the diameter and radius. Because I have noticed when I'm working with you guys one-on-one that sometimes we still get a little bit tripped up with this. And it's totally fine, so we're just going to work it out together. I have a radius. How do I find the diameter? You double it. So you double the radius to find the diameter. So that means we're just going to do 2.5 times 2. If I don't know what it is right away, I'll just come over here and do 2.5 times 2. And I get what? 5. Do I have to put 5.0? No, you don't have to. 5 feet. Well, what if I have 9 feet and I want to find a radius? How do I find that radius? I divide by 2, right? I'm going to do 9 divided by 2. Is it going to come out evenly? No, it's not. How many times does 2 go into 9? Evenly. 4. And how much is left over? 2 times 4 is 8. 9 minus 8 is 1. And I have 1 left over. 4.5. Now, if you want to see that written out like this, it's 4 and 1/2. Okay. Could I say 4.5? Of course, we could say 4.5. How about letter C? 4.5 feet. And how do I find a radius? Divide by 2. Now I have 4.5 feet divided by 2. I'm going to erase this real quick. So I'm going to take my 4.5 and I'm going to divide by 2. What do I have to do first? Backwards C. Good. Let's backwards C. 4.5 becomes what? 4 times 2 is 8, plus 1 is 9. 9/2. What do I do with the divide? Make it a multiply. What do I do with the 2 over 1? Make it a 1 over 2. And then what do we get? We just multiply across. Whoa, what happened? We just multiply across, so we get 9/4. Now, can I change 9/4? I sure can. 9 divided by 4 goes 2 times. 2 times 4 is 8, minus 1. So we get 2 and 1/4 feet. Okay, guys. Today, your assignment, you are going to look, your assignment for tonight is to go to page 347, and I would like you to work on numbers 10 through 21. These are Pemdas problems. Remember with Pemdas problems, what is the very first thing we look for when we have a Pemdas problem? We look for parentheses. If there's no parentheses, we move on. Do we have exponents? If we don't, then we move on. Then we do multiplying and dividing in the order they appear. If dividing comes first from left to right, we do dividing first. If multiplying comes first, we do multiplying. Then the very last step is to do the addition and subtraction in the order they appear. I will attach the PEMDAS video to Google Classroom so that you guys can watch it again before you do page 347. So you're going to watch the PEMDAS video, the Don't Stress video. It's going to be in your head all day. You're welcome. Before doing page 347. Okay, guys, we'll see you tomorrow. Great job today. Bye.